Thank you very much. And I'll introduce myself for the sake of those that join us later on. My name is Mai Bukar Adama. I'm with the National Space Research and Development Agency, Abuja, Nigeria. So I'm here to share work we did on drought monitoring and assessment in Northern Nigeria. Next, please. So drought, as I earlier said, remain one of the most pressing climate-related hazards in the country. And it is actually a prolonged period of below average precipitation that may result in water shortage, also affects agriculture, ecosystem, livelihood, and so on. It can vary in intensity, and its impacts are often influenced by regional climatic conditions and water management practices. So this drought usually affects or should I say Northern Nigeria is most vulnerable to drought as a result of climatic conditions. Naturally, this region receives low and very low and erratic rainfall, and it experiences long dry season and a very short rainy season. Next, please. So the aim of our study was to assess the spatio-temporal variability of drought pattern in Northern Nigeria. And the objectives are to examine long-term precipitation trends across the northern region, which comprises of Northeast, Northwest, and North Central Nigeria, using precipitation data, of course, and to compute and analyze Standardized Precipitation Index for each of the regions, and to also compare regional differences in precipitation trends and SPI values. Next, please. So as I earlier mentioned, I said the three regions are the Northeast, the Northwest, and the North Central. They are actually characterized by the same climate and then seasonal rainfall, which is the arid, the semi-arid climate. So the map you see there is for the Northeastern region. Next, please. And this is map for the North Central and then the Northwest, that's showing the study area. Next, please. So the data and tools used for this research, we actually use the Google Earth Engine platform, which is a very powerful platform, a very powerful cloud-based platform that requires you to not need a very powerful machine to carry out. And then another advantage is that it has a massive geospatial data catalog like the Landsat, the MODIS, and carry out your analysis. It is free and accessible, very fast, and it has a very powerful visualization tools. So, and then another advantage it has is that it can be integrated with other tools as well, like the other GIS platforms that we have to carry out analysis. So the rainfall data was the climatic hazard group infrared precipitation with station data, which is the CHIRPS data. It's actually a quasi-global rainfall data set developed by the Climate Hazard Center at the University of California. It combines satellite imagery with in situ station data to provide high resolution daily to monthly precipitation estimates starting from 1981 to date. So, and then the boundary shape file, of course, of our study area is also used as an asset from the Grid3 platform. And then the Google Earth Engine platform was what was used for our analysis. Next, please. The methodology used for this research was adopt a practice recommended by the UN SPIDA. It was we decided to adopt the methodology, and then it was the Standardized Precipitation Index, which is a commonly used index to analyze drought conditions based on precipitation deviation from a long-term average. So the table you are seeing there is the drought classification table, and you can see that values range from minus to plus. Positive SPI values, they indicate wetter than normal conditions, while the negative values signify drier than normal conditions. And to your right is the flow chart of the methodology adopted from the UN SPIDER platform. Next, please. So as earlier mentioned, the platform we used was the Google Earth engine, which I said is a very powerful platform to carry out social analysis. So what we did was we adopted the method from the UN SPIDER, as earlier mentioned, and then copied the Google Earth engine script to GE platform, and then we brought in area of interest, the boundary shape file of our area of interest, and then run our analysis. So the results we have there, the map you're seeing there is for the northeastern part of the country. We realized that the SPI values are more positive. They are positive towards the northern part of the region compared to the southern part of the region, signifying that the northern part had wetter condition than the southern part within the study period. So below is the precipitation chart showing the annual 12-month precipitation sum of the region. Corresponding to that, to your right is a graph showing the SPI value for the period of 10 years. That is the study period. Next, please. Next, please. Okay. So, no, sorry. Can you go back one slide back? Okay. And this is the same analysis carried out for one of the regions, which is the Northwest. You can see that it has a similar result with the northeastern part of the country. Also, the northern part of the region has more positive SPI value than the southern part of the region. This is because they have a similar climatic condition in the two regions. Next, please. And this is for the North Central, which we commonly also call the Middle Belt. You can see that the SPI value here is distributed. There's no any specific region dominating the other, any specific part dominating the other part in this very region. That's because it is located in the Guinea Savannah zone, unlike the Northeast and then the Northwest region. Next slide, please. So the Northeast appears to be the most vulnerable to climate variability with alternating droughts and then excessive precipitation periods, while the Northwest exhibits moderate fluctuation, indicating some resilience. And the North Central region maintains a relatively stable climatic trend over the observed period, making it less susceptible to extreme wet and dry conditions. Why we carried out this analysis is because understanding these regional differences is actually very crucial for developing targeted climate adaptation strategies to reduce vulnerability of these regions. So thank you very much for your time.